Hello, in this video we're going to discuss the chain rule for finding derivatives. The chain rule applies to functions that are composed of compositions of two separate functions. So I'm just going to write it generally at first, and then we'll look at some examples. If you have, say, a function h of x, which is f composed with g of x, the derivative of h of x is the outside derivative, f prime, recopy g, and then multiply by the derivative of the inside g prime. That's the chain rule. With just some really easy cases here, we could say y equals sine of x squared. In this case, the inner function is x squared, the outer function is sine. When you do the chain rule, you have three steps. The first step is to write the derivative of the outer function. So for us, the derivative of sine is cosine. That's the first step. The second step is to recopy the inside function without changing it, x squared. Finally, the last step is to multiply by the derivative of the inside function, which is going to be 2x from the power rule, and that is an example of the chain rule. If you have something like this, 3x squared plus 5 squared, we'll start with it with a low power. This can be done using the chain rule or with the power rule after multiplying this out. So I'm just going to go ahead and multiply it out for starters, just so we can compare side by side. 9x squared, 9x to the fourth, plus 30x squared, plus 25 is that multiplied out. The derivative here, using the chain rule, would be the outside derivative. That's something squared. Recopy the inside, and then multiply by the derivative of the inside, which is 6x. So that's one example of the derivative of that function. Also, you could do the power rule here, 36x cubed plus 60x. And I'm not going to compare these two with the algebra, but if you multiply this out, you would get the same thing. I guess we can. We've got 2 times this is 6x squared times 6x is 36x cubed. And 2 times 5 is 10 times 6x is 60x. So they are the same. Now, in this case, either one was, it didn't matter really which one you used. But say you have one where you have a much more, much larger power. Say you had 3x squared plus 5, again, to the 8th power. Now, the algebra that would be involved with this would be just astonishing, multiplying 3x squared plus 5 out to the 8th power. So in this case, you can see where the chain rule really comes into being useful. The first step of the chain rule out of 3 steps is you bring the 8 down, drop the power by 1 to 7. That's the power rule for that outside function. Recopy the inside, and then multiply by 6x, which is the derivative of the outside. You can clean it up a little bit, I suppose. So that's just the chain rule in the most basic format. Let's just step it up a little bit, and we'll do a square root of secant plus tangent. Not too bad. We're going to start out by calling this secant x plus tangent x to the 1/2 power. Anytime you have a root, you're almost always better off writing it as a exponent with a fraction. And y prime here is going to be 1/2. Drop that power to negative 1/2. And now that's the first step. The second step is to recopy the inside. And then hopefully you know the derivative of secant and tangent. The derivative of secant is secant tangent. and then the derivative of tangent is secant squared. And I'm just going to rewrite this one more time as a fraction. 2, down here we have the square root of secant tangent. Up top we have a secant tangent plus secant squared. So that's my derivative from the chain rule. Sometimes you'll have a nested chain rule, and sometimes you'll have the chain rule combined with other rules. So before we do a nested chain rule, let's just look at one where we have the chain rule combined with other rules. I'm going to do r of theta is 2 theta times the square root of secant theta. So what you need to do first is recognize that yes, we're going to have a chain rule, but the first order of business is a product rule, where you have f is 2 theta and g is going to be secant theta. I'm going to call that to the 1/2 power. So now f prime is 2, and g prime is going to be a chain rule because we have an outer function, something to the 1/2, an inner function of secant. So the first step is to write 1/2, drop that to the negative 1/2. And then the second step is to recopy the inside secant theta. And then the last step is to multiply by the derivative of secant, which is secant tangent. And I almost am running out of space here. Secant tangent. I'm just going to kind of write it down there. Humor me. Times secant tangent. And now we're going to put those pieces together. So back from the product rule, we're going to have f prime times g plus g prime times f, 2 theta times 1/2 secant theta. I'm sorry, try that again. The 1/2 should have been times 1/2, and then secant theta to the negative 1/2. That should have been, the half had to be outside the parentheses, times secant theta plus tangent theta. That's the derivative of r. I'm going to clean it up down here. R prime of theta is 2 square roots of secant plus, give you some space here, 2 theta times 1/2 is 1 theta. 1 theta times secant theta plus tangent theta all over secant theta. So that's your derivative. We've got the product rule primarily, but in the middle of this we did have a chain rule to go from g to g prime. So this is kind of what makes the derivative rules hard. It's when you start combining one with the other. If I just give you 20 problems of the product rule and say go for it, that's really probably pretty easy because you know what you're looking at. But the hard part is when you don't know what you're looking at exactly. You have to kind of sniff that out for yourself. I'm going to take this paper off and we'll keep rolling here. Okay. The next thing I want to do is I want to do a quotient rule that involves a chain rule, and then after that we'll go to the nested chain rules. So I'm going to do y equals fraction x over square root of 1 plus x squared. F is x, and g is, I'm going to write this as 1 plus x squared to the 1/2 power. F prime is 1, and now g prime is going to involve a chain rule. So we're going to just kind of take a moment with that. I'm going to bring the 1/2 power down. Drop that down to negative 1/2. Rewrite the inside unchanged. That's the second step. Finally, the third step is multiplying by the derivative of 1 plus x squared, which is 2x. And now we're going to just use the quotient rule and put the pieces together. While we're here, I'm just going to say g prime 2x times 1/2 is 1x. And then I'll write this as over square root of 1 plus x squared, because that negative means my square root goes down to the bottom. So here we go. Y prime is f prime times g. That's going to be 1 times the square root of 1 plus x squared minus g prime times f. That's going to be x times x, which is x squared over square root of 1 plus x squared, and then all over g squared. So if you square a square root, you just get 1 plus x squared there. And that's that. You could simplify this a little bit more. If you were to look at a problem like this in the back of the book, they might actually go multiply every single term by root 1 plus x squared. Let's just do that for laughs. I'm going to do, this is just algebra, it's not calculus anymore, but it's something that still confuses people. So basically we've got these three terms in a big compound fraction, and if you were to just multiply by root 1 plus x squared over 1, both the top and bottom, I suspect the back of the book would do this. So if you ever have a multiple choice where you're not sure why they got the answer they did, basically this times this would be just 1 plus x squared, and then minus this times this, the top and the bottom would cancel out, then you'd have minus x squared, and then you'd have 1 plus x squared to the 1. This is really 1 plus x squared to the 1/2, so you'd have 1 plus x squared to the 3/2, and then they would x squared minus x squared go, so you'd have 1 over 1 plus x squared to the 3/2. And then in the back of the book, they come down and they write 1 plus x squared to the negative 3/2, and they'd say that's your answer. And you just look at that and say, what in the world? I got this. So being able to use algebra to simplify things sometimes really is challenging, but it comes in really handy. So just a little word of warning there for you to simplify the compound fractions. On the AP test, especially when you look at multiple choice questions, sometimes the multiple choice answers are simplified in a way you're not expecting. Okay, let's go to the nested chain rules. Let's try y equals sine squared 3x minus 2. I'll just move this up there. So I'm going to just go ahead and rewrite this before we actually start as sine of 3x minus 2 squared. By writing the trig function like this, you can see that more clearly what the outside function is and what the inside. The outside is something squared, then the inside is sine 3x minus 2. So we're going to start this out with my first rule. My first rule is this. Do the derivative of the outside function, stop. Second, you're going to recopy sine of 3x minus 2 and just recopy that inside. And then last, you're going to multiply by the derivative of sine of 3x minus 2. The reason I call this a nested problem is now the sine of 3x minus 2 itself is another chain rule. Now sine is the outside, 3x minus 2 is the inside, so you have to go through your 3 steps all over again. The derivative of sine is cosine. The inside is 3x minus 2. And then the derivative of the inside of 3x minus 2 is 3. So when you clean all this up, you get y prime is going to be 3 times 2 is 6 times sine of 3x minus 2 and cosine 3x minus 2. And I just want to show you another issue that you're going to run into when you check in the back of the book for a problem such as this, is they're going to say, recall your double angle formula for sine. This has nothing to do with calculus, but it still is something they're going to throw at you. They're going to say, recall this. This is a fact from trig. This is one of the 5 identities that I mentioned that you need to know. Out of all of trig, there's 5 identities. This is one of them. The three Pythagorean identities: sine of 2 theta, cosine 2 theta. If you know those 5, you're good. So look up here. We've got sine of theta, cosine theta. Here we've got sine 3x minus 2, cosine 3x minus 2. I'm going to go ahead and rewrite y prime as 3 times 2 sine 3x minus 2 cosine 3x minus 2. And so now we've got this form is right here: 2 sine of something, cosine something, 2 sine of something, cosine something. Flip over here to the other side of the equal sign and you see that we've doubled the angle, and this is now going to be equal to 3 times sine of 6x minus 4. And that is going to be the derivative. This is certainly right. It's not wrong. But if you try and use a multiple choice question, or if you're taking a multiple choice question, use this as your answer, or this as your answer, it may not be one of the choices. So another just warning about simplifying your answers. I want to try another nested problem. So take this off, and we're going to flip this page over, use the back side. And this one is going to be an even more hairy nested problem. Y equals 1 plus cosine squared of 7x. All of that is going to be cubed. Now this is going to be a triple nested chain rule. Holy smokes. But we're going to start out just like any other chain rule. We're going to do the y prime equals 3. I'm going to use brackets here just to kind of keep everything clean. Bring the power of 3 down. The outside function is cubed. Drop the power by 1, so that's the power rule. Step 1 is done. We're going to rewrite 1 plus cosine squared of 7x inside. And then last, we're going to multiply by the derivative of cosine of 7x squared plus 1. So just take a, let's go down here for a minute and just make a note. If you have 1 plus cosine of 7x squared, say that's g of x, the derivative itself is going to be a chain rule. The derivative of 1 is 0, thankfully. 2 comes down here and drop the power by 1. Rewrite cosine 7x. And then multiply by the derivative of cosine 7x. The derivative of cosine is negative sine. The inside part is 7x. Recopy that. And then finally just multiply that by the derivative of 7x, which is 7. So this all is what goes up there. You can see we have 3 different chain rules. Negative 2 and 7 make negative 14 times cosine 7x sine 7x. And I've probably not used my paper very well, but that's okay. I'm just going to come down here. Y prime is going to be, now I'm going to kind of pull the same trig trick that I just did, because I know that the book's going to want me to do it. So I'm going to take negative 7 out here, and we'll have negative 21. 1 plus cosine squared of 7x squared times 2 sine 7x cosine 7x. So I'm just kind of cleaning this up, and I've written this now in the format of the double angle formula for sine. Once again, I'll just write it down. Sine 2 theta equals 2 sine of theta times cosine theta. And so y prime is going to be negative 21 1 plus cosine 7x squared. And then this right here is going to turn into sine of 14x. What I had before was not wrong. Absolutely not. I would count that right. But, you know, why not just clean it up as much as possible with the double angle for sine. So this wraps up the chain rule. You can do as many nesting examples. You can have 2 loops, 3 loops. Typically, I would doubt that on an AP test you would ever have more than 3. Probably wouldn't have more than 2. Just make sure you feel comfortable with the chain rule and especially the nested problems.